All right, now we're going to do the first problem from the third ACSL quiz in 2013-2014. And the most important thing to do with these Boolean algebra problems is to make sure you read the question very carefully. So we're looking for which ordered triplets make the following Boolean expression true. Not how many, but which ones. So this is going to require some math, but the first thing that I always do is simplify the expression as much as you can so you don't have to deal with a lot of unnecessary terms later on. These problems can all be done a lot of different ways, so it's really important that you find your path and make sure you know which way works best for you before taking the quiz. So the first thing I'm going to do is multiply out these first two groups of terms. And what you're going to get is AB times not A plus AB, B, C plus not C times not A plus B, C times not C, and then all of that is times A plus not B plus C. Now using our rules that we learned before, we can simplify some of these terms. So this term here, and this term here can all be simplified. The first one, we know that something can't be both itself and not itself, so that term is just 0. This term, when you have A and B twice, you can simplify that and just write it as A and B and C. And this term, using the same logic as the first term, it can't be both C and not C, so this term is also just 0. So now we're just going to rewrite our equation, and we get A, B, C plus not C, not A times A plus not B plus not C. All right, so from here, this is pretty much as simplified as we can go. And this is when I use, personally, the Broner method to make my table and to find the ordered pairs. So we're just going to go to a clean page because it takes some room, so make sure you use lots and lots of paper. So just rewriting what we had before, it was A, B, C plus not A, not C times A plus not B plus C. All right, so now we're going to make our table. First thing you make is the A column. Now, to know how many ones and zeros you need, you look at how many different variables you have. Since a variable can either be 0 or 1, you know that each is going to be a multiple of, or a power of 2, so you know how many ones and zeros to put. So we have 3 variables, so there are going to be 8 different options. So I'm going to start by putting 4 zeros in the A column, and then 4 ones. And then B, I do 2 zeros, 2 ones, 2 zeros, 2 ones, and then C is going to be 0, 1, 0, 1, 0, 1, 0, 1. And these are all of the possible combinations for A, B, and C that you could have, and we're going to see which makes this expression true. So the first thing to do is your first term. So that's A and B and C. And now we're going to look for when A is true, B is true, and C is true all at the same time. So we can see that this is false, 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 and the only place that they're all true is down at the bottom, so we're going to put a 1 there. Then we look at our second expression in the first set of parentheses, which is a not A and a not C. So to do that, I always divide up by first getting your not A and then your not C, and then putting it together to make sure you don't skip any steps. So not A is going to be the opposite of A. So that's just 1, 1, 1, 1, 0, 0, 0, 0. And C is the opposite of not C. So that's going to be 1, 0, 1, 0, 1, 0, 1, 0. And then our term that we're looking for is not A and not C. So that's when both not A and not C are true, or when A and C are both false, whichever is most intuitive for you. So I see here that I have a not A and a not C, and both are 1, so that's 1, 0, 1, 0, 0, 0, 0, 0. So there are 2 times when not A and not C are both true. All right, now we do the full expression. So that is A, B, C plus not A, not C. And we know that the plus means or. So we're looking for a time when either A and B and C is true or not A and not C is true. So make sure you're very careful with your columns, but I'm just going to highlight which columns we're looking at. So we're looking at this one here and this one here. All right, so then we're looking when either one is true. So that's a 1 up here. Oops, sorry. It's a 1 up here, and then a 0, 1, 0, 0, 0, 0, 1. So only in these 3 spots is that true. So now we need some more space, so we're going to do our second set of parentheses on a page. And that expression that we're looking at now is just A or B, not B, or C. All right, and I'll just rewrite our A column and our B column and our C column. I always start with these columns whenever I begin any Boolean algebra problem, just so you have them there right next to you while you're working. And these terms are pretty basic. The only one that's different from the ones that we have is our not B here. So I'm just going to change that to, so whenever B is false, make it true, and whenever B is true, make it false. All right, so there's not B, and now we are looking for when either A is true, not B is true, or C is true. So again, be careful with your rows and your columns, but we're looking at this column here, and this column here. So whenever you see a 1 in any of these columns, this expression is true. So this will be true, true, false, true, 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 true. So there's only one spot in which it's false. All right, so now that we are done with this expression, we're going to put them both together. And remember this column here, I'll rewrite it again, but as you can see, this takes a lot of room, so make sure you spread out. And the final expression that we're looking for, just once again, is as follows. All right, so we're looking at these two, and we found a truth table for each one. And since we already found those two, I'm just going to rewrite them here, and then we can go from there. So the first term was A, B, C plus all of that, and the truth table for that was as follows. So 1, 0, 1, 0, 0, 0, 0, 1. And then our next one was A plus not B plus C, and that was true a bunch of times. So 1, 1, 0, and then the rest of these were all ones. And then the whole expression, I'm just going to write it as and, because it's this expression plus and this expression. So I forgot a parentheses there. So just to save time from rewriting. And this is going to be true only when both of these are true. So you see 1 is here, and then 0, and then 0 again, 0, 0, 0, 0, 1. So it's only true at this value here and this value here. So now the final question again was what makes the whole expression true? So what makes this expression up here true? And to give you the answer, that requires you going back to that ABC column I first drew and seeing when the ones here correspond with the values for A, B, and C. So the first column, here's A, B, C, they were all off because it always starts with a 0. So we know that this value is going to result in a 1 up here. And then the column progressed and we had some zeros for A, 0, 1, 0, 1 for B and C. And finally, the last part of the column, which is where we're looking for here, they were all 1s. So this pair is also going to give you a 1 here. So your final answer for this question is 0, 0, 0, and 1, 1, 1.